Hello, everyone. So, today, the problem that we are going to discuss as part of the data structure and algorithm on array is set matrix zeros. So, this is also a very popular problem, which is medium level. And this problem is also asked in many interview questions. So, let's quickly go and understand this particular problem in a simplistic way, and then we'll see how we approach this particular problem uh, how we approach. Yeah, so when I say how we approach, I simply mean that we will understand that how we are trying to uh, find the solution of this particular problem. So it should be in a better way, rather than, our approach should be more, uh, I would say it should be more better, because we should not jump to the optimized solution straight away. Rather, we should talk with the interviewer, as I always emphasize in my previous videos, that we should talk definitely about the brute force. So brute force is very important. So let's quickly read the solution, and then we will understand how we can solve this solve this problem. So yeah, given m cross n integer matrix. So what does it mean? That this particular matrix that we are talking about is m cross n. If an element is 0, set its entire row and column to 0. Meaning, if that particular element, let's say this is 0, so we have to set all its column and all its row equal to 0. And that's what we have to achieve. So you see here, this is input array, and then you have to turn it in like this. So if input array matrix is 1 1 1 1 0 0 0, this whatever it is. So if an element is 0, you have to set its entire row and columns to 0. So you have to do this check for all the cells, in the entire matrix, and you have to do this for all where you found element 0. So that's what you have to do. Very simple problem, right? Isn't it? So yeah, so that's pretty much all about the problem. I think we can quickly start and write the code to understand it, like how we will solve this particular problem. So I'll quickly go to my IntelliJ. I create a class which is, let's say, set matrix uh, zeros. Great. And then over here, I just copy my comments and then some input. All right. Yeah, and then one more input could be here. So let's say this is example 1, and then example 2 is here. All right. So now let me create a main method, input, logic, output. Okay. All right. So what is input? Input is my matrix array. All right. So I create a two-dimensional matrix array, matrix, and then I will just copy all this over here. I have to change this to curly braces. This is how Java compiler understand an array. I mean nested arrays. All right. So the Java compiler is happy. Now, what we have to do, we have to write some logic here so that this particular uh, copies 2 times. All right. So we have to write some logic so that this particular matrix array got its result right. So see, the brute force approach is very simple. What you will do, we will use an auxiliary matrix, okay, of list of list. You know why list of list? Because you're talking about a two-dimensional array. So list of list will definitely make a matrix. You make it auxiliary matrix to store whether each cell should become 0 or not. Traverse the matrix, the real matrix, and whenever a cell is 0, mark its corresponding row and column in the auxiliary structure. So what does it mean? So you have your auxiliary matrix. Let's say you make that auxiliary matrix, give it a type 2 boolean. So all the values in the auxiliary matrix will be false. And then when you are iterating your real matrix, wherever at particular I index you get cell value equal to 0, what you will do, you will mark that particular auxiliary matrix ij wherever you found 0 equals to true. And once you are done with that, what you have to do in iteration 2, you have to update matrix. Okay, so again you will iterate the matrix which you have created, the auxiliary matrix. So wherever you have true, it means you have 0. If that is the case, you have to traverse the matrix and then set the rows and columns to 0 as per the auxiliary structure. So what you have to do, if your auxiliary matrix at particular ij index is true, what you have to do for that particular row, for example, k is equals to 0, k less than rows, k plus plus, you have to do matrix kj is equals to 0. And then similarly, again k is equals to 0 to k less than columns, and then for matrix ik is equals to 0. So you can solve this particular problem in a brute force approach having an auxiliary matrix. You can create an auxiliary matrix with boolean, and whenever you found 0, you just mark it true. And then since you have to update the original matrix, then what you have to do, you just need to go to real matrix again you iterate on your auxiliary matrix. If ij of your auxiliary matrix is true, then you do two for loops inside that. So again, two loops for the iteration of the matrix, of course auxiliary matrix, and then inside that inner loop you will check if it is true. I mean the auxiliary matrix element is true, you have to take care of the whole row and whole columns of that particular cell, right? Wherever that particular cell belongs. So for k is equals to 0 to till k less than rows, k is equals to 0, k less than columns. And then you make ik or kj equals to 0. That's what you do. So time complexity of this method is O of m dot n dot m plus n. Why? For every 0 found, you may iterate through the row and column again. Okay, so that is the reason why this m plus n comes in picture, because you have to move rows and columns for every single m cross n iteration you get it. Space complexity O of m cross n. Now, instead of using auxiliary structure or auxiliary array, can we do it in place? Like, can we do it as the problem was here? You must do it in place. So, can you do it in place? Yes, we can do that. And how we can do that is something that we will see as part of the solution of this particular problem. So, instead of auxiliary structure, we can use the first row and first column of the matrix to mark whether a row or column should be zeroed or not. Okay. So what we will do, instead of having an auxiliary matrix, we can use first row and first column of the matrix to mark whether a row or a column should be zeroed or not. Use a boolean variable, let's say isCall, to track whether the first column itself needs to be zeroed, and then you will traverse the matrix. If a 0 is found at I comma j, mark I matrix I0 and matrix 0j as 0 and process the matrix again. So when you process the matrix again, 0 out cells based on the markers in the first row and first column. So you have to 0 out. And then you have to handle the first row and column separately at the end, because what you did initially, you made your first row and first column of the matrix to mark whether a row or column should be zeroed or not. So you were using those first row and first column as the markers, right? So now at the end, you also have to fix them back. So you need to handle the first row and column separately at the end. And this will reduce the time complexity of brute force to O m cross n. and before it was OM cross N multiplied OM plus N. So it was much more time complexity, kind of adding you O of N cube approximately. And over here also, when we are doing inline, we do not need to create any auxiliaries array or matrix, so it will be space complexity O of 1. So let's quickly code the solution in a way. So I will do inline, okay, set zeros, and then I pass my matrix here, and then what I will do in my output, I need to for int, okay, it should be row matrix because this is the real matrix, and then for it will be val of that row. Okay, and then it's int val, and then I'll do a out, and over here print, I will print val plus give some space, and then because I want to format like matrix, so I just give a space for the next row. All right. So this is how my problem solution on a very high level structure look like. Let me quickly create the method. So remember, I told you what we have to do. We have to first create a Boolean variable. Let's call, oh, sorry, we need to create Boolean and let's call it is call and then make it false. Good. And then I create int rows. How many rows? Rows will be my matrix dot length. And then in calls, it would be matrix 0 dot length. All right. And then for I, and this will be rows. And then for, okay, so over here, what would I have to do? So now I started for all the rows. So I is equals to 0 till all the rows. If, so this is the first marking of first row and first column. Okay. Okay. So matrix of I 0 is equals to 0. If that is the case, what I will do, I say is call is equals to true. Okay. And then for j is equals to 1 till j calls, what I have to do, I have to check if matrix of I j is equals to 0, then I will do matrix of I 0 is equals to 0, and then matrix of 0 j is equals to 0. All right. So quickly explain you in a moment like why I'm doing this. Coming to the next part, which is, I mean, this is where so you see this particular problem. We talked about the solution of the problem, like for example, how we actually we first try to mark first row and first column, okay, and then we go and check for the remaining rows and remaining columns. So whatever logic you see right here is marking logic. So I can put my comment here, mark rows and columns. All right. So this loop here, it iterates through the matrix and mark rows and columns that need to be zeroed using the first cell of each row and column. Okay. So for each row, what we will check if the first column element is 0, correct? So what does it mean? So if yes, this line says if first column element is 0 for each row, if first column element is 0, this represent like x and y. So y is 0, it means this is I mean, if you say I is equals to 0, so you're talking about rows and columns. So I is increasing, it means you are at first column, because column is fixed. This is row, but this is column is fixed. So first column of a particular row, if it is equals to 0, then what you have to we are setting that is call is equals to 2 to remember that entire first column must be zeros later. Yes or no? Yes. So that is why we are marking this first column. And then over here in this loop, what we are doing, for each cell ij in the matrix, skipping the first column, because first column already been marked. Okay. Now j is equals to 1. For each cell I comma j, skipping the first column for now, if value is 0, if the value is again 0, then what we have to do? Set the first cell of that row, matrix I0, first cell of that row is equals to 0. Set the first cell of that column, first cell of that column, 0 comma j to 0. These act as markers to indicate that the entire row or column needs to be zeroed. So this is the marking process. Okay. I'll explain you one more time. But yeah, let's go to the second pass, which is also very important to understand. And there we will update matrix based markers. So whatever markers we made here, we have to update our matrix based markers. So what we will do now, we will create an array. I mean, we will of course iterate my array. So for I, and over here I less than rows, and I have to start my I to 1, and then again it will be j always start with 1, and it will be cos. And then what we are going to do is if matrix of I 0 is equals to 0, or matrix of 0 j is equals to 0. If that is the case, what we have to do, matrix of I j is equals to 0. So this is what we do here. And why we are doing that? Now again, now we are done with the markers. Okay, what we have done in the markers, one more time, just for a better understanding. So we have to loop through the matrix and mark rows and columns that need to be zeroed using the first cell of each row and column. Okay, so that is why what this logic will do. So for each row, check if the first column element is 0. For each row, we check the first column. If it is 0, we say is call equal to true. Okay, if to remember that the entire column must be zeroed later. Okay. Now, second, for each cell I comma j, if value is 0, meaning in the matrix for each cell I comma, if value is 0, then we have to set the first cell of that row, matrix I0 is 0, and first cell of that column, matrix 0 comma j to 0. So we have to make sure that we mark first cell of each row, first cell of each column as the markers to 0 if they are they need to be zeroed. Okay, so these are the marking techniques. Second pass, now we traverse the matrix again, starting from the second row, of course, because first column and first row has been taken care, second row and second column. Okay, and zero out cells based on the markers set in the first pass. So we have already set the markers, okay, in the first pass. So that is why we have to do use that particular thing. So now rows column, and then if this is equals to 0, now we have to do ij 0, because that particular cell uh, if has to be set equal to 0, because either matrix of I 0 marker for the row is 0 or matrix 0j marker for the column is 0. So that is why we must set matrix of ij is equals to 0. Now, what we have to do, because we are done with full matrix, but we have done something here in the first column and first row. What we have to do? We have to fix them back, right? So now we have to handle our first row, okay, and now we also have to handle our first column. So how we will handle? That is simple and but also tricky. Okay. So if matrix of 0 comma 0 is equals to 0, then we will do for I, wait, for I is equals to I is equals to 0, I less than calls I plus plus, and then I will do matrix of 0 comma j is equals to 0. Uh, I, all right, and then I will copy this for loop, and over here I will say if is call is true, what I have to do, I again have to do this, but this time it will be rows, and I comma 0, I comma 0 has to be 0. Yeah. So what we are doing here, we have to handle our first row and handle our first column. So over here what we see, if first row must be 0, its top left corner must be 0, right? So that's why we're checking. If this is equals to top left corner is 0, in that case, we will 0 all the first row elements. So over here, all the first row elements is 0. So 0th row and all element like moving to the right. I is column, right? So it is all set to 0. Entire row 0. Now handle the first column. What we have to do here? So if is call is true from the first pass that we have done, now we have to 0 out the entire column. So that's why is call is true. Then we just entire column will be 0 out. Let me quickly run this and see how this solution works. 00005500310. That's good. I will quickly submit this and see onto the IntelliJ how the solution looks, and then we will discuss about time complexity one more time. Okay, here we go. Copy, paste. Let me check if I'm not using anything from the util. Okay, we are not using. Let me run this problem. Solution. All right, it is accepted. Let me submit it. So the solution is accepted and submitted by Leetcode. So now we're talking about the time complexity. So I think the problem is pretty clear. So this approach, we are talking about the time complexity is O of, like when we talk about brute force, the time complexity of O of m dot n multiplied by O of m plus n. Why? Because in the previous step, what we were creating first an auxiliary array, and then we were using the auxiliary array to uh, to store some identifiers for each cell which has to be 0, and then we were traversing the matrix, and then every time when we were traversing the matrix, we were checking the auxiliary array matrix, of course. If it is 0, then for the complete row and complete column, that is m plus n, we do for loops, two more for loops to make all 0 for rows and for all 0 for columns. So iterating a matrix is of O of n dot n, and inside jth nested loop, we were doing two more for loops utilizing the auxiliary array if it was marked as true or false, and then marking the entire row and entire column as 0. So that was O of m dot n multiplied O of m plus n. But over here, when we talk about space complexity for the brute force, it was also of O of, I would say, uh, space of the auxiliary array, right? Auxiliary matrix that we were using. So O of m dot n, like the total number of elements in the particular entire matrix. Now, when we come to the optimized approach, what we have done. So over here, you see, this is simply a loop where we just did the marking first row and first column. Okay. And then over here, this is again O of n square, like m dot n. Uh, and over here, you see it's O of n, again O of n. So total time complexity is O of n square. And the space, we have not used any space, so it is O of 1. So time complexity is O of m dot n, where m and n are the total number of elements in a row and column, and space complexity is O of 1 because we are not taking any space. So thank you very much. We see you in another video.